When we talk about quantum information and quantum technology today, we're really talking about how fundamental physics is transforming what we can do technologically, what we can do as a society.
We know that we live in a quantum world. We've known that for more than a century, but the ability to actually reach down to the quantum level and both manipulate things and also tell what we're doing in a controlled way, that's something that's been a very recent development.
I would consider what is happening now maybe a second revolution of quantum mechanics.
One thought is, can you build quantum computers?
Quantum computer will have computing capabilities that currently not even all the most powerful computers present at the moment put together can possibly enable.
The first applications that are probably going to happen that would impact a broader community are related to secure networking and communication.
It would be a much faster internet and a much more powerful internet in the sense of giving you the power of quantum computing.
Then people can begin to develop devices and instruments and tools for our world that can do things that we couldn't do before.
History has plenty of examples of that type of fundamental research leading to really profoundly impactful technology like lasers, magnetic resonance imaging, things that you might not have dreamed of when you first started playing in the lab.
At CERN, when we have the Large Hadron Collider, we're colliding two protons together, and then boom, things come out, like a Higgs boson comes out. We don't actually know how to simulate that physical process of the protons smashing together and other things coming out. So even the world's biggest supercomputers aren't good enough to do that, and what we're hoping is that eventually quantum computers can help us solve some of those really hard quantum problems.
This is an exciting prospect for the different areas of quantum computation, of quantum sensing, of making networks of quantum devices, doing quantum imaging, which could get in medical applications.
If we have the ability to get down to the individual cell-by-cell map in a quantum-based MRI machine, our ability to detect cancers and detect other things would be a momentous jump for healthcare.
Another application area will be using quantum processors as a tool for quantum simulation. That means to design new materials, new chemicals, new pharmaceuticals.
We want to harness this capability in the future as it comes to fruition. As we continue to explore out in the solar system, you'll want more and more communication as our instruments create more and more data. And certainly as you think about sending humans to Mars, everyone's going to want a high bandwidth, high definition, real-time television from Mars to see what's going on. So if quantum allows us to do that better, more efficiently, more effectively, that's a winner.
There will be a role for connecting the devices together in a quantum way. So we looked at the thing and said, look, we're a networking company. If there is a future of quantum computing with interconnected devices, we want to facilitate this new world because this is an important thing to do.
Because as we better and better understand where the technology is going, we realize that we are just beginning to scrape the surface of what might be possible.
Industry, research academia, plus government. Everyone is excited to get involved, and we may get foundations and investors. With a few of this type of consortia and cross-consortia coordination, we can have a global quantum technologies revolution.
Well, I think it's important for the country for us to maintain our leadership and innovation.
It's exciting, and we want to work hard to enable such a technology.
And what I would say to the general public is watch this space. Something interesting is going to happen.